In the last section of chapter 4, we're talking about arithmetic sequences. And by the end of this lesson, you will be able to recognize and extend arithmetic sequences, as well as find a given term of the arithmetic sequence if I asked you to. But in order to be able to do this, you need to first know what an arithmetic sequence is. So on your note guide, before we do the warm-up, let's define it. An arithmetic sequence is a sequence where the terms, you need to finish the sentence on your note guide, write it down, differ by the same non-zero number. So D is the common difference. So you're looking at a pattern and you're looking for the numbers to differ by the same non-zero number, common difference. So write that down and I'll try A with you on the warm-up, and then I'm going to have you try B and C on your own. When you're looking at these sequence of numbers, you're looking for a pattern and you're looking for a common difference. So what's the difference between these two terms? What's the difference between the next two terms? Those differences should be the same. So 13 minus 9, the difference is 4, or that I added 4 to the first term. What I do from 13 to 17, well, 17 minus 13 is 4, or from 13 I added 4 to get to 17. And then on the last one, 17 plus 4 gives me 21. So this is an example of an arithmetic sequence. And my common difference would be 4. So we're going to use D to represent the common difference. And the common difference would be 4. Try B and C. Look for that pattern. See if you have a common difference. If you do, it's an arithmetic sequence. So try those now. Then we can go over them together. So as you tried them, now you can check your work and see how you did. On this problem, we're adding a half to each one, or 5/10. So it is an arithmetic sequence, and D is 5/10. The last one is not an arithmetic sequence. You may mistake it though for one. Here we added 1/3. Here we added 1/3, but on the middle, you actually added 2/3. Because negative 1/3 plus 1/3 would get you up to 0. So you're over here at negative 1/3. You add 1/3, that would get you to 0. And then add 1/3 again, and that would get you to the positive 1/3. So you actually added 2/3. This is not an arithmetic sequence. So you have the definition written down of an arithmetic sequence. You've practiced identifying now. This is the work that you have to show, by the way. That's the only work you have. So do write down you checking each difference. Another example in an arithmetic sequence would be 3, 5, 7, 9, and so on. And from this one, you could find the 7th and the 25th term if I asked you to. 7th term, okay, we're just adding 2, so let's extend this. 11, 13, 15, 17, 19, 21. So the 7th term would be 1, 2, 3, 4, 5, 6, 7. The 7th term would be 15. Take a minute and find the 25th term. So keep listing them out. As you're listing them out, you can see the problem with this. We don't always want to have to list out all the values. So keep going until you find the 25th term. I'm waiting for you to find it. But this is the problem. What if I asked you to find the 250th term? It would take way too long for you to list them all out. So we want to come up with a shortcut or an equation that's going to allow us to find any term of an arithmetic sequence without doing all that work. So hopefully you found it. The 25th term came out to be 51. So let's try to come up with an equation that is going to allow us to do this quicker instead of having to list them all out. First, we need to be able to write and notate some things. In algebra, we have specific ways we write things. So we're going to use A to represent the term in the sequence, okay? And you're going to add a subscript to that. So if you add a subscript of 3, that's A sub 3. This means that's the 3rd term in the sequence. A sub 5 would be the 5th term. A sub 10 would be the 10th term. If we wanted to designate any term then, or the nth term, we would write A sub n. So we want to come up with an equation that says a sub n, or any term in the sequence, can be found how? Let's think about this equation, this sequence first. Looking at this one, the first term is 3, and we're going to write the first term in algebra as a sub 1. That's the first term. Well, to find the second term, we took 3 and we added 2 to it, right? Because that was our common difference. So we got 5. Our third term, we took 5 and added 2. But I don't want to write it always relating it back to the previous term. If I did that, I would always have to know what came before it. If I wanted to find the 250th term, I would have to know the 249th term. And then I would have to know the 248th term. It's going to take way too long. Can you relate the third term to the first term? We got 7 from 3. How? We added 4, or we added the difference twice, right? We added 2 times that 2 again. The fourth term came out to be 9. Can you relate 9 to 3? Looking for a pattern, so don't say multiply by 3 here. Let's continue on with this adding. We wanted to add 2. How many times would you add 2? You would add 2. Oops, sorry. You would add 2 3 times. Well, what about the nth term? If I wanted to find the nth term, we're coming up with a pattern. So the second term is always going to be the first term plus the difference, right? And the third term is always going to be the first term plus 2 times the difference. The fourth term would be the first term plus 3 times the difference. Do you notice a relationship between the term number and the number of times you add the difference? Between the term number and the number of times you add the difference. Between the term number and the number of times you add the difference. What's the relationship there? What do you see? Try to write an equation using all variables without saying that the difference here is going to be 2 in this problem, but using d for difference. How do you come up with it? Well, hopefully you're seeing that we're always going to have the first term and we're always going to add that difference to it, but how many times do we add the difference? Well, it's whatever term number we want to find, 1 less than that. So it's n minus 1. So this is your equation, and you can turn the page and write it down in the box at the top. The nth term of the arithmetic sequence with the common difference d and the first term of a sub 1 is this. Think about a ruler. I think it helps to think about a ruler when you're doing this. If you think about a ruler, you might have, this might be, the 3rd inch, the 4th inch, the 5th inch, 6th, and the 7th inch. On that number segment, I have 1, 2, 3, 4, 5 numbers, but I have 1, 2, 3, 4 spaces. 5 numbers, 4 spaces. So on the 5th term, I only add the difference 4 times, right? It's 1 less than the numbers. Let's try this then. Find the indicated term of the arithmetic sequence if you want to find the 22nd term, and this is the start of the sequence. We're going to want to label a sub 1, n, and d for all of these problems, so write that down. Fill in as much as you know. A sub 1 is your first term. What is your first term in the sequence? In this one, it's 5. N is the term number you want to find. So what term number do you want to find? The 22nd term, you're finding 22. So a sub 1 is the first term. You may want to write it down. N is the term number that you're looking for. And d is the common difference. So what is your common difference in this one right here? Well, we subtract 3, subtract 3, subtract 3. I'm just checking and making sure they're all common, so my difference is going to be -3. So let's plug in what we know here. We have a sub n equals a sub 1 plus n minus 1 times the d. Substitute in everything that you know. I want to find the 22nd term, so n is 22. The 22nd term is the first term plus my term number minus 1 times the common difference. Now just simplify. So I want you to be doing it on your paper. Hopefully you're going ahead of me a little bit. That would be great. The 22nd term is going to equal what then? Did you get negative 58? That's what I have, so hopefully you have it too. Keep this label on your answer because this says the 22nd term is negative 58. So you can be given the sequence. You could also just be given the information. If you look at the next example, in example B, it says I want to find the 60th term, and I'm telling you right away my a sub 1 is negative 5, and my d is negative 2. So you have the a sub 1, you have the d, and the 60 represents what letter again? N. Go ahead and try this one, then press play to go over it. So pause the video now. So when you did this problem, hopefully you substituted everything in, and you have that the 60th term comes out to be negative 5 plus 60 minus 1 times negative 2. Be careful with your signs here. So a negative times a positive is going to be a minus or a negative. 2 times 9 is 18, carry the 1. 2 times 5 is 10, plus the 1 is 11. And then we have a negative 5 in front of that. So the 60th term ends up being, there we go, the 60th term is going to be negative 123. Box that whole thing in, keep your label on there. The last one I want you to try is C. D is going to be an optional challenge for you. So C says the odometer on a car reads 60,473. So the odometer tells you how many miles the car has been driven. So the car has 60,473 miles. Every day the car is driven 54 miles. What is the odometer reading 20 days later? So this one's a little tricky. This 20 days later is a little tricky. What is your A sub 1, your D, and your N? Take a guess here. Write those down for me. So A sub 1 is what you're starting with. We're starting with 60,000 miles, 473. The difference is what's changing. Each day the car is being driven 54 miles. The N is the tricky part because the N is the term number. If I want 20 days later, am I talking about the 20th day or the 21st day? Since it's 20 days later from where you are now, this is actually the 21st day. So you're going to do this problem with N being 21. Pause the video, try this. You may need a calculator for this one, then press play to see the answer. So I hope that you've tried this problem. Let's check your work here. To find the 21st term, we'd be looking at this equation. And what it comes down to being is 61,553 miles. So on the 21st day, or 20 days later from where you are now, the car would have 61,553 miles. If you're feeling up for a challenge, try D. I'm going to put the work on Blended Schools so you can check out the answer after.